We can divide all materials in the world separate ways. Today I am going to introduce a different parameter. It is conductivity. In electronics we differentiate materials as conductors, insulators and semiconductors. Conductors. A conductor is a type of material that allows the electrical current to flow through it. From the microscopic view, by subscription of ionization electrons create a current. But, with increasing of temperature the electron conflicts rising and resistance will increase. The conduction electronic band has more energy than valence band. Due to this overlapping, a small potential difference across a conductor causes the free electrons to constitute electric current. Insulators. An insulator does not allow the electric current to pass through it, due to its high electrical resistance. In the insulators, the energy gap between valence and conduction bands is very large. Therefore, a very high electric field is required to push the valence electrons to the conduction band. The bonds between molecules are very strong. But when rising temperature breaks molecule bonds and occurring active electrons. These electrons can create a current. Therefore, the insulators have negative temperature coefficient of resistance. Semiconductors. This is the topic that discussed deeply. Semiconductors having conductivity in between conductors and insulators. Reason for the conduction of semiconductors is disengage free electrons and holes from atoms due to rising temperature and doping. Holes means positive charge carries. In a semiconductor, the forbidden energy gap between valence and conduction bands is very small. Therefore, a smaller electric field is required to push the free electrons from valence band to the conduction band. At low temperatures, the valence band of semiconductor is completely full and the conduction band is completely empty. Thus, a semiconductor behaves as an insulator at low temperatures. As temperature increases, more valence electrons cross over to the energy gap to reach to the conduction band and the conductivity increases. This shows that electrical conductivity of semiconductor increases with the rise in temperature. Let's talk about intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors. A semiconductor material in its pure form is known as an intrinsic semiconductor. They are not doped with other molecules and free from impurities. As an example, we can discuss about pure silicon semiconductor. Silicon atom has 14 electrons and 4 in the outer shell. An atom shares these 4 electrons with other 4 atoms from covalent bonds. When temperature increase, some electrons absorb energy in advancing to the conduction band. Then they broke the bonds and release from molecules. There is one thing you must remember. When an electron release, positive charge hole occurs in the molecule. In an intrinsic semiconductor, the number of electrons is equal to number of holes. When supply external electrodes, these electrons move towards positive side. This is the procedure of flowing a current in an intrinsic semiconductor. Direction of current is opposite to electron flowing direction. The electric conduction is dependent only on temperature. When temperature increases, bonds between semiconductor molecules are broken. Then releases more electrons and emerge holes. As a result of this current will increases. Second part is extrinsic semiconductors. When a small amount of chemical impurity is added to an intrinsic semiconductor, then the resulting semiconductor material is known as extrinsic semiconductors. The extrinsic semiconductors are also known as doped semiconductors. The process of adding impurity in the intrinsic semiconductor is known as doping. The doping of semiconductors increases their conductivity. There are two types of charge carries in extrinsic semiconductors. The first one is majority charge carries. Electrons or holes occur due to doping is called majority charge carries, or main element that participate to electric conduction. Second one is minority charge carries. Electrons or holes occur due to temperature raising is called minority charge carries. Based on the material type of doping, the extrinsic semiconductors are classified into two types. They are N-type semiconductors and P-type semiconductors. 1. N-type semiconductors. When a pentavalent impurity is added to an intrinsic semiconductor, then the resulting semiconductor is termed as N-type semiconductor. As examples, doping of phosphorus or arsenic. In the compound there is one extra electron per pentavalent atom, so that in N-type there are more electrons. As we said before, the majority charge carries are electrons and minority charge carries are holes due to temperature. 2. P-type semiconductors. When a trivalent impurity is added to a pure semiconductor, then the obtained semiconductor is known as P-type semiconductor. As examples, doping with aluminum and boron. Due to the lag of one electron in trivalent atom, there is a one extra hole per atom. Holes participate so much to flow current in P-type. Then we can say majority charge carries are holes and minority charge carries are electrons. Among these two types, N-type semiconductors have more conductivity, because they have more free electrons. Usually, electrons are mobility than holes, so that N-type allows flow current quickly. The major advantage of extrinsic semiconductors: there are more electrons or holes in the material. I added only one pentavalent atom electron and more electrons slip due to increasing of temperature in the animation. But you must remember, in real-world conditions, a relatively small amount of electrons slip due to temperature.